In a previous lesson, we saw that the points on the xy plane, 3, 4, could be turned into the form 5 cosine 53.1, comma, 5 sine 53.1. We did that by taking the square root of 3 squared plus 4 squared equals 5. That was the r value, which is the thing that goes here and here. And for the angle, we did tan inverse of 4 over 3, which became 53.1 degrees. We didn't have to move it. This is in quadrant 1, so that just ended up being theta. A similar thing can be done when we're dealing with a point on the complex plane, because 3 plus 4i is kind of like the point 3, 4. So by the same kind of reasoning, square root of 3 squared plus 4 squared equals 5, and tan inverse of 4 over 3 equals 53.1. So instead of writing it as 5 cosine 53.1, comma 5 sine 53.1, we could write this as 5 cosine 53.1. Instead of comma, we could say plus, and it's 5 sine 53.1i, but usually we write the I in between the 5. So this is called the polar form of a complex number. Sometimes people will factor the 5 out. And sometimes a real shorthand for this is just to say 5 CIS 53.1. Those are all shorthands. I personally like this way for understanding what's going on with it, but these other forms are allowed. Now I'm going to do this for two other points. One is going to be the point 5, 12, which is up here. Sorry, not 5, 12. 5 plus 12i. So 5 plus 12i, the r value for that one would be the square root of 5 squared plus 12 squared, which is 13. And the theta value for that, in the first quadrant, you just have to do tan inverse of y over x, which ends up being 67.4 degrees. So the 5 plus 12i in polar form could be written as 13 cosine 67.4, not comma, but plus 13, put the I in between the 13 and the sign, so 13i sine 67.4 degrees. So I changed both 3 plus 4i and what was originally 5 plus 12i into this polar form. Now, if I multiply together 3 plus 4i times 5 plus 12, if I do that in rectangular form, we get 15 plus 36i plus 20i plus 48i squared, which is the same thing as minus 48. Minus 48 goes together with the 15 to become minus 33 plus 56i. Now back to here. If I were to graph minus 33 plus 56i, it would be some point way up there, much higher, triple this, but I don't have enough room for it. So that's minus 33 plus 56i. If I draw these three things to scale, maybe they look, whoops. Something like that. This is the 3 plus 4i. Here's the 5 plus 12i. And here's the big minus 33 plus 56i. And there's no real obvious relationship between the two things that are getting multiplied together and the product, which is this big thing here. Now remember, the 3 plus 4i in polar form was 5 cosine 53.1 plus 5i sine 53.1. And remember, the 5 plus 12i was 13 cosine 67.4 plus 13i sine 67.4. Now, if I take the answer and I try to turn that into polar form, the r value would be the square root of 33 squared plus 56 squared. We don't need to use the negative 33 because it's going to get squared anyway. And it would end up becoming 65. For the theta, because negative 33 plus 56i is in quadrant 2, it would be 180 minus tan inverse. Remember, again, don't use the negative signs at all. Just say 56 over 33. And you get 120.5. So the negative 33 plus 56i could be written as 65 cosine 120.5 plus 65i sine 120.5. And I want you to pause for a second and see if you notice the relationship between the two numbers that were multiplied together and the product now. Okay, so I hope what you noticed is that the 65 is the product of 13 times 5, whereas the 120.5 is the sum of 67.4 and 53.1. And that's not a coincidence. That's a major rule in complex numbers. So I'm going to write it down. Here it is written down as a pretty intimidating looking rule, but it's basically saying that once the two complex numbers are written in polar form, to get the answer in polar form, you would just multiply together the two r values and add together the two theta values. We'll get proofs of that another time. But here's some ways some questions we can do with this really important rule. The easiest type of question is if they give you both numbers already in polar form and ask you to write the answer in polar form. In that case, you just multiply together the two r values and add together the two theta values. In this case, if they want to turn the answer back into rectangular form, we could, even with no calculator, because cosine 60 is 1/2. And sine 60 is radical 3 over 2. So 6 plus, we usually go 6i root 3. We also put the I in between a number and its square root. But if they just asked for the answer in polar form, we would leave it just like that. Now, a question we can do with this process just to practice, it's not that we would ever want to do this question this way unless we're told we must do it this way. It gives us a unusual way and tedious way of multiplying two complex numbers. So, yes, of course, we could do FOIL and answer this question in just a few seconds, but we want to practice polar form and the multiplication rule, so we're doing this other, much more complicated way, and it goes like this. For the first number, we can calculate out the R value. It ends up being about 4.12. And the theta value is, this is in the first quadrant, so tan inverse of 4 over 1, which is about 76 degrees. For this other number, and it's a really good idea to draw even the most basic sketch of these just to see at least what quadrant I'm in. So the R value here is the square root of 5 squared plus 2 squared, which is about 5.39. And theta 2 is in quadrant 2, so it's 180 minus tan inverse of just regular 2/5, positive 2/5. Don't put negatives into the tan inverse, and you get about 158.2. So these numbers in polar form are 4.12. I'll use one of the abbreviated forms here just because it's less writing, a little less writing. Cosine 76 plus I sine 76 times the other number is 5.39 parentheses cosine 158.2 plus I sine 158.2. Now, according to the multiplication rule, I can multiply 4.12 times 4.39, which is 22.2, which is going to be the R value for the answer. And the angle is going to be the sum of 76 plus 158, which is 234.2. This one I'm going to put the R in front of, I'm going to distribute it through. And that's actually the answer in polar form. But they want the answer in rectangular form. Seems like a lot of work to do, but if you pop this into the calculator, just type in 22.2 times cosine 234.2, out will come negative 13. And if you put 22.2 times sine 234.2, out will come negative 18. We'll round to the nearest integer at this last stage. And yes, that is the same answer that you would get if you just did it the easy way with FOIL. That's okay. Don't worry that this is a much longer way to do the same question. It is going to be useful for some other things that are coming up, so I want you to be able to do it this way, even though, of course, our original way from last year gets us the same answer a lot more quickly.